Hello ladies and gentlemen, welcome to part 2 of our session. So they're asking us to evaluate a limit of 5x minus 2 over 7x plus 3 when x approaches infinity. So let's try by using direct substitution. So by direct substitution we are going to substitute infinity wherever where we see x, we just substitute infinity plus 3. But what is 5 times infinity? So this statement means that this infinity will increase 5 times. And even if we subtract 2 on the infinity, it will just decrease by 2, but the infinity is too big, it will just be infinity. And then even here, the infinity will enlarge by 7, and if we add 3, we just increase the infinity, so it will just be infinity. So it's infinity over infinity. So we can see that this is the indeterminate type infinity over infinity. So what can we do now? We can use L'Hopital or limit rules. So now, before we solve this, I want you to know that limit of x approaching infinity of 1 over x to the power n equals to 0 when n starts from negative infinity all the way to positive infinity. That will always give us 0. So now we are going to solve this in a way that we have something like this. So limit of x approaching infinity of 5x minus 2. So here we are going to take this x and then we take it outside the bracket. So if we factorize this, we are going to have x, and then here we are going to have 5 minus 2 over x, because of we are making the x common factor. So if I multiply into the brackets by x, I'm going to get 5x minus 2. And then even on the denominator we do the same. 7 plus 3 over x. So if I multiply by this x inside the bracket, I'll get 7x plus 3. But now x will just cancel out x, we can see that. So we are going to have a limit of x approaching infinity of 5 minus 2 over x all over 7 plus 3. This is the same as 3 times 1 over x. And then even here is the same as 2 multiplied by 1 over x. So we can see that our n is actually 1. So let's try to distribute this limit. So let me cancel this. So if we can try to distribute this limit, we are going to have a limit of x approaching infinity of 5 minus 2 limit of x approaching infinity of 1 over x, all divided by limit of x approaching infinity of 7 plus 3 limit of x approaching infinity of 1 over x. So since 2 and 3 are actually scalar, that's why we are taking them outside. That's why we are taking, we are actually putting them here, because of limit of x approaching infinity of a, when a is a constant x, ax, this will be the same as a limit of x approaching a of x. It's just an example. So now this will just give us what? This will just give us what? A limit of a constant is constant. So limit of 5 when x approaches infinity. This just shows us that when x approaches infinity, then we are going to have 5. So it will just be 5. So what about here? Here is going to be 0, because of is a limit of 1 over x to the power n, and our n in this case is 1. So it's just going to be 2, 0. this whole thing will just go to 0. Divided by, and limit of constant again, it will just be 7 plus 3. So we can see that this is 1 over x to the power n, and our n is 1 in this case. This will also go to 0. So our limit will just be 5 over 7. Our limit will just be 5 over 7. So we can try using L'Hopital and see if we get the same thing. Because we should get the same thing. Because by the law, we know that the limit of x approaching a of fx over g over x equals to the limit of x approaching a of f prime over x over g prime over x. So we know this. So since this part it gives us 5 over 7, even this part must give us 5 over 7. Now, we can say limit of x approaching infinity of 5x minus 2 prime over 7x plus 3 prime. So by actually differentiating inside of the brackets, we are going to have a limit of x approaching infinity. So the differentiation of 5x is just 5. And when we differentiate 2, it will just give us 0 because of the gradient of a constant is always 0. So this will give us 0 over, even here, when we differentiate this, we are going to get 7. And then when we are going to differentiate this 3, because of its constant, it will always give us 0. So we are actually having what? A limit of x approaching infinity of 5 over 7. But what did I say? 5 over 7 is constant in this case. So what is the limit of a constant? Is always that constant. And what is our constant? Our constant is 5 over 7. So now we can see that 5 over 7 is actually equals to that 5 over 7. So if you enjoyed this session, please like, share and subscribe. And hopefully we are going to see you on our next session.